All right, for this section, we're going to go ahead and start looking at analyzing a graph of a quadratic function. We're going to start with the graphing of y equal to x squared plus q for some values of q, and then a little bit later on we're going to switch that and graph y equal to x minus p in bracket all squared. There are two different things that is happening to the graph of a quadratic function for different values of p and q. I'm going to explain what they are and what it does. First, though, I want to make sure that we know that the parent function of a quadratic function is written as y equal to x squared. That's a very basic, we call it a parent function. All right, so everything is actually reference to the parent function for when we are comparing. All right, so the very first thing we're going to do, we're going to graph y equal to x squared, and then once we have that, we're going to add or subtract, or depending on what values of q we're going to use, we're going to see what happens to the graph. So we're going to use Desmos. So we're going to go to Desmos again. So here's Desmos. I open up the Desmos again. And the very best first thing that you would do is that you open up a new page, new graph, and simply you punch in. Now you could just say x squared, and then you come down here. Actually, let me bring this down a little bit just that you can see what is happening. So the x squared button is, you have to go to the keyboard, you open that up, and that's the x squared button right there. Okay, so that's the x squared button, and you can just do that and it will show, or you could put a y equals in front of it and it will be the same. It doesn't matter. Okay, so you can do either way, it's okay. All right, so that's the very first thing we want to do. The grid is to scale the vertical, the domain and range. The x-axis and the y-axis, they're partitioned equally so that you can see the symmetrical part of the graph, or the symmetry of the graph, I guess I should say. All right, now let's see what happens when we add. So I'm just going to go add another one by just pressing the enter. When I press an enter on my keyboard, it just goes down to the next. That means it creates another one. So randomly, we're going to choose. So we're going to start with x squared again. Here is x squared, y equal to x squared. All right. But now I'm going to add, let's start adding 1. Now the blue graph is the new one. The red is the parent function. Now look at it and see what is happening. So it went up. The graph moved up. Okay, now moving up, it's interesting by saying moving up is that the lowest value of the graph, or the floor of the graph, the coordinate right there, which is 0, 0 at origin, right there, is now moved up to 1, 0. Okay, now let's do the enter again, and let's do y equals x squared. This time, let's do plus 3. What happens now? Look at it and notice that it moved up 3. So 1, the graph, original graph, the parent function have moved up. 3 is moved up by 3. Now let's do negative. Let's do y equals x squared. This time minus 1. That's a purple graph. Look what happened. It dropped down, and this coordinate, which is a very crucial point, and we're going to label that, we're going to title it, we're going to name it, is 0, minus 1. And minus 1 is showing up here, as you notice. That's a minus 1 right here. Okay, and if we do last one, y equals to x squared, and we can keep doing that until you see the pattern, but I'm thinking that you already see the pattern now. Let's do minus 5. Actually, let's do minus 4 so we can see it on the grid. All right, here it is, minus 4. So the black graph. So what can you say about the value of p, which is what is added to the x squared? Now, if we go back to our notes, what can we say? Sorry, that was q, not p. What is the what can we say about the Q, the effect of Q to the parent function? That is a very important thing that we need to do, and based on that, we need to try to navigate through the uh, the the graph. All right. So in y equal to x squared plus q, what it does is that this q right there, if it's positive, that is being added to the x squared, the graph moves up. Okay, so right there, that's a very important piece. The graph moves up, moves the graph up right there, and that is when it's positive. And when it's negative, it goes down. The graph goes down. The graph based on the reference to the parent graph or parent function. Okay, so Q makes the graph going up and down is just the vertical translation. So another way of saying that is the vertical translation is happening based on the original graph. So Q goes up and down, and that's the vertical translation. Now, what is in each of those graphs? Let's look at and write the coordinate of that important point where we have the graphs. So look at the y equal to x squared. That's the red graph. All right, so right there, let me actually, and you can do that by clicking on each of the graph. They hide. So what is the coordinate of this minimum value of the graph? What is the total of the x and y value? Well, you can see that it is, if you click on that, you can see that that's 0 0. Okay, so 0 0 is right there. So that actually, it is called the vertex. That is the name of that important point. The vertex of the parabola is the point where the graph changes the curvature. Okay, so that is where the direction changes. It's coming down this way, and then it hits that, and that's the bottom piece, the minimum value, and then goes back up. That is the vertex. Now, it can be upside down. We're going to talk about that too. It's the same idea. If you look at that, it can also have the maximum value. Okay, so that's what we have. So let's go back. So in y equal to x squared plus q, the vertex is 0, q, and 0 is the x coordinate of the vertex, and q is the y coordinate of the vertex. And when it goes up, it will be, the graph goes up because 0 doesn't change, it stays. And if it goes down, q is negative, goes down, and 0, the x value of the vertex doesn't change, and it stays 0. So that is the influence of q based on being positive or negative, and influences the graph. The vertical translation happens only when q changes.